वेलकम स्टूडेंट्स। आज हम मिसलेनियस एक्सरसाइज ऑन इनवर्स ट्रिग्नोमेट्री के प्रॉब्लम करने वाले हैं। नाउ एक्सरसाइज चैप्टर 2 दिस इज बेस्ड ऑन एनसीईआरटी बुक। तो एनसीईआरटी ना प्रॉब्लम नंबर वन फाइंड द वैल्यू ऑफ क्वेश्चन नंबर 1 इज दिस। Find the value of cos inverse cos of 13 pi by 6. So this is our problem. Question is a problem. Cos 13 pi by 6, we consider only the principal value branch. Principal value branch in this case, in this question, for the cos inverse is 0 to pi. So only consider the angles which lies in first and second quadrant. This is first quadrant, this is second quadrant, and this is the angle from theta is equal to 0, and this is the angles theta is equal to pi. So consider only the angles in the first two quadrant. So here if I consider 13 pi by 6, your 13 pi by 6 is the angles more than 2 pi plus pi by 6. So it means that one complete rotation would be 2 pi, and here more than 2 pi means this is pi by 6 is 30 degree. 30 degree comes out in the first quadrant. For these questions the angle is this is the angles 13 pi divided by 6. So it means that one complete rotations, the rotation end starting from here and end is here. So yes, so we also know cos using the formula of cos 2 pi plus theta. Cos 2 pi plus theta will be cos theta, because cosine is positive in first quadrant. So just replace this one, cos inverse, replace here cos 2 pi plus pi by 6, bracket is closed. Yes, so yeah, now it becomes cos inverse cos 2 pi plus means cos pi by 6, cos pi by 6 30 degree, and this 30 degree belongs to in 0 to pi. This pi by 6 belongs to the principal value branch of cos inverse. So it will becomes pi by 6. So the value is pi by 6 of this question, problem number 1, pi by 6. Now in next problem, question number 2. So find the value of tan inverse of tan 7 pi by 6, 7 pi divided by 6. So here we remember the principal value branch of the cos inverse is minus pi by 2, open intervals at extreme left and right extreme. This is the principal value branch of tan inverse x. So considers only the angles which lies and first and fourth quadrant. In first quadrant, so this is the first quadrant, the angle is pi by 2 here, pi by 2, and this is if I rotate clockwise, then this angle will be minus pi by 2. So it means that this is the fourth quadrant, first and fourth quadrant. If the angle lies between first and fourth quadrant, then it will become principal value branch of tan inverse x. So here 7 pi by 6, we just split this. Tan inverse tan of pi plus pi by 6, I have split it 7 pi by 6. So yes, so this is the pi plus third quadrant angle. So this is third quadrant angles, it would be here somewhere. So this is the angles of 7 pi upon 6. So in third quadrant, tangent has the value 10 pi plus theta. This is the formula we will use, plus tan theta. So this is the formula then used here, tan inverse, and then side bracket 10 pi plus this will be 10 pi by 6. Now pi by 6 30 degree, and this 30 degree obviously inside of this intervals. So here pi by 6 belongs to this open interval, minus pi by 2 to pi by 2. So now, so that's why tan inverse or 10 pi by 6 will be pi by 6. This is our answer. Now in question number 3rd, our question number 3rd, we have to prove 2 sin inverse 3 by 5. To prove 2 sin inverse 3 upon 5 is equal to tan inverse 24 by 7. Tan inverse 24 over 7. So now this is our formula. It is very simple, sir. Here we will use triangles. Make it triangles here for make it right angle. This is our angle theta, and just opposite of this is a 90 degree. Here from this sin theta, if I find out the value, sin theta is equal to P by hypotenuse. So this is our P perpendicular, this is a hypotenuse, this will be base. So here P by so sin inverse 3 upon, let us suppose sin inverse 3 upon 5 is theta, sin theta 3 upon 5. So here this the value 3 upon 5. 3 upon 5, 3 will be this one, 5 will be this one. Using the Pythagoras theorems, it will become 4. So here, so now from here, if you do find out the value of tan theta here, tan theta from this this problems, tan theta 3 by 4. 3 by 4. So let us do this problem. So now 2 sin square 3 upon 5. 2 sin square 3 upon 5 can be converted into tangent function. So here in both the cases theta is equal to, here if theta is equal to sin inverse 3 upon 5, from here tan theta is equal to 3 upon 5 will be tan inverse 3 upon 5. Three upon 4, not 5. So yeah, this is our convergence for convergent triangles. So now we will do from the right hand side, not right hand side, we do from the left hand side. This is our left hand side. In our left hand side we have the value 2 sin inverse 3 upon 5. So this will converge into, we know tan theta is equal to sin inverse 3 upon 5 and also equal to tan inverse 3 upon 4. We replace sin inverse with the tan inverse 3 upon 4. So now this become 2 times of tan inverse 3 upon 4. So using the formula here, we will use here the formula. This is the formula for this problem. 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x. This is the formula we will use here. 1 minus x square. This is the format of 2 tan inverse x. So using the formula here, tan inverse 2 times of 3 upon 4, 2 times of 3 upon 4 divided by 1 minus 3 upon 4 square of this. Now close this bracket. Now after that, so the value becomes here tan inverse, just simplify the 3 by 2 divided by, after this 1 minus 9 upon 16. So now this value becomes here 9 upon 16 tan inverse 3 by 2 divided by, taken the LCM, 16 minus 9 will be 16. After taking the LCM, 16 minus 9, yes, 16 minus 9 will be 7 upon 16. 7 upon 16, just simplification it. So 3 by 2 multiplied 16 upon 7. 16 upon 7, and replace this so now this comes out 24 by 7. 24 by 7 is the answer of this question. Final answer becomes here tan inverse 8 into 3, 24. 24 divided by 7. Yes, so this is our right hand side. So right hand side, so we have very easily using this triangles. First converts this sine inverse into tan inverse, sine theta, sine inverse into tan inverse. Then using this final formula, this is the formula we have used here in problem number 3. So question number 4 is question में we have left hand side both are sin inverse 8 upon 17 plus sin inverse 3 upon 5, right hand side tan inverse 77 upon 36. So so it is easier. There are two ways to solve these questions. First, using the formula sin inverse x plus sin inverse y. Another formula is convert this sin inverse, these two sin inverse into tan inverse, then using the formula tan inverse x plus tan inverse y. So here, so make a triangles. We are using the simpler which one converts the sin inverse into tan inverse. So this is the triangle, right triangle. This is the right triangle theta. So here let us suppose if I go from the beginning, sin inverse 8 upon 17, sin inverse 8 upon 17 is equal to theta. So from here sin theta is equal to 8 upon 17, 8 upon 17. So this is right triangle, just opposite of this theta. Sin theta is equal to p by hypotenuse, perpendicular upon hypotenuse. So our perpendicular is 8. This will be our 8 and hypotenuse will be 17. Now using the Pythagoras, this base will be base has the value square root of square of 17 minus square of this one. So this value after 189 minus 64. So it becomes finally, now square of 17 to 89. Now by simplification, 289 minus 9 minus 4 is 5, 8 minus 6 is 2, and here 225. 225 is the square of 15. Purchase. Yes, this is square of 15. Yeah, 15. So our base will be here 15. So from here tan theta, using the formula tan theta is equal to p upon base. So p is 8 and base is 15. So therefore theta will be tan inverse 8 upon 15. This tan inverse 8 upon 15 is also equal to sin inverse 8 upon 17. So in this way uh, we have converts 8 upon 17 into tan inverse. Similarly we will convert this sin inverse 3 upon 5. So sin inverse 3 upon 5 in this triangle, if I replace this one, so sin inverse 3 upon 5, sin inverse let us suppose 3 upon 5 theta is equal to this one. So this will be 3, this will be 5, and this becomes 4 by using the Pythagoras using the Pythagoras theorem. Yes. So from here sin theta sin inverse 3 upon 5 tan theta, same way as we did in explained in earlier part, and tan inverse theta tan theta will be here 3 upon 4, to therefore tan inverse 3 by 4. So 3 by 4. So tan theta p by base to 3 upon 4. So final answer is here after conversion. So sin inverse 8 upon 17, 8 sin inverse 8 upon 17 converts sin inverse 8 upon 15, tan inverse 8 upon 15. Tan inverse 8 divided by 15 and sin inverse 3 upon 5 converts into tan inverse 3 by 4. So now here using this formula, tan inverse x plus tan inverse y, use here this formula, tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. This formula is valid only when 1 should be greater than x and y. You can only use this formula when 1 should be greater than this. So let us check whether we using here is not. So obviously here product of this one 8 upon 15 upon into 3 by 4. If you simplify this ones, 8 3 by 4 2 and 3 2 by 5, this value is less than 1. So this value is less than 1, so we will use here. So now finally using this formulas here, this become tan inverse sum of 8 upon 15 plus 3 by 4 divided by 1 minus product of these two, 8 upon 15 3 by 4. Now close this square bracket. Now after simplification it becomes tan inverse taking the LCM 15 and 4, 15 and 4 it is 60 the LCM, and 32 and 45 over Again taking the LCM here, 15 60 go this side, minus 24, cancel and cancel. Now final answer becomes here tan inverse 35 17 और 2 7, 5 plus 2 7, 4 3 7, 77 divided by 60, 60 minus 24, 4 6 and 5 2 3, 36, 77 upon 36. So this will become our right hand side part. So in this way we did very easily using this formula tan inverse x plus tan inverse y. This is simplest formula. Now next question, question number 5. Question number 5. Cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. Cos inverse 33 upon 65. So we will use here either if you do like this problems, convert these two all three in the tan inverse, and then using the formula of tan inverse x plus tan inverse y is equal to these ones. Either using the tan inverse x, tan inverse y formula here, we will use second case using this formula tan inverse x cos inverse x, cos inverse x plus cos inverse y will be cos inverse xy minus root of 1 minus x square 1 minus y square. So this is the value we have. Now this formula will be valid. ये formula तभी यूज करेंगे when here x and y, these two numbers should lie between minus 1 and 1. First thing, now second one, x plus y greater or equal to 0. Adding these two will be greater or equal to 0. Let us check out. Obviously 4 upon 5, 12 upon 13. These two are 4 upon 5, 12 by 13. Obviously these two numbers 4 upon 5, 12 divided by 13 is obviously lies between minus 1 and 1. And the next adding these two number 4 upon 5 plus 12 divided by 13. If you take obviously this value some इन दोनों का सम 0 से बड़ा होगा. Let us solve this question. So using this formula now, cos inverse x, here cos inverse x and y, 4 into 5 and 12 by 13, x into y minus root of 1 minus 4 upon 5 and into 1 minus 12 by 30, square of 12 upon 30 whole square. Now simplify this uh, cos inverse, if you simplify this one, not cancelling denominator numerator, 48 divided by 65 and minus, taken the LCM, 25 minus 16 and 25 multiplications, 169 minus 144 divided by 169, bracket is closed, and now here, now is equal to cos inverse 48 upon 65, 48 upon 65 minus, simplification, 25 minus 16 will be 9, it will be 3 by 5 into 169 minus 144. Now this value is 25, yes, 9, no, yeah, 25, this become 5, 25, 25 divided to 169, it 25 upon, it comes out 5 upon 13 hoga, correct, 16. Now cancel, solve it. तो फाइनली इट विल, हमारे पास जो आंसर आ जाता है, टेकन द एलसीएम हियर, 65 इज द एलसीएम and 48, 40 denominator part, and 5 15, minus 15 will be this one, minus 15 will be this one. Now cos inverse 65 in the denominator and 48 minus 5 is 8 minus 5, 3, 4, 30, 33. Cos inverse 33 divided by 65. It will be divisible by somewhere. Yes. Achha, no, not division. So now this become our right hand side. So this will be our right hand side part.